Welcome to our NLP class. This is part 11. In this class, we are going to learn about Naive Bayes Classifier. So, let us consider the example, the movie review. I liked the movie. The movie was awesome. Here, after applying the pre-processing steps, we end up with getting this list of words. The list of words has these words like movie, awesome. The stop words will get removed. The I, the was. These words will get removed and the liked will become like. So, this would become my uh, feature vector. So, what do I do that on this feature vector? We'll see what is the conditional probability. The conditional probability is probability of, so given it has the word x1, what is the probability of this complete sentence is positive sentence. How do I calculate this probability value? Using the Bayes formula. The Bayes formula says that it is equal to probability of positive class over probability of this x1, which is multiplied by probability of x1 given it is a positive class. So, this is our Bayes formula that we saw in our previous class. Using this formula, we can calculate the probability of the sentence being positive only for the word x1. How do I expand this formula that covers all the words in the sentence? So, x1 could be either awesome, movie or like. If I want to look at the entire sentence and predict whether the sentence is positive or not, I want to include all the words in the sentence. What is the likelihood of the sentences being positive when I look at the word like? Like would be more probably positive sentence, awesome would be more probably towards the positive sentence, but we are not sure about the movie. So, in order to include all those words in this Bayes formula, we use this Naive Bayes classifier. The basic assumption in Naive Bayes classifier is it is each feature in this sentence is independent and there are no correlation between those features. The assumption says that like, movie, all these words are independent, which may not be true in NLP problems, because when we look at that English sentence, some of the words are sequential and it possesses some information. But this Naive Bayes classifier, it has the simple assumption that each word is independent and there are no correlation. So, based on this assumption, this formula can be rewritten as covering all those features x, probability of the sentences being positive sentence, the condition it has the x, this is x, equal to, what we do is we just multiply these formulas for every words in the sentence. Probability for x1 given it is positive and probability for x2 given it is positive, probability of x3 given positive, etc. And probability for this particular class, the class is positive. This is the formula to measure the likelihood or the probability of the sentences being positive. Similarly, can we calculate similar probability score for the negative? So, if it has the positive sentiment of 0.7, it may have the negative sentiment of 0.3. So, we want to measure this value as well. How do we calculate? It is just the same formula, replace all these positives as negative probabilities. So, probability of negative given it has x is equal to probability of x1 given it is negative into probability of x2 given it is negative, probability of x3 given it is negative. Then finally probability of the negative class. Do you remember what we saw in our previous class? We need to combine these two, find out the ratio between the positive probability and negative probability. Not the positive negative probability, it's a probability for the positive score and probability for the negative sentiment, which is equal to probability of positive sentence for the given x vector divided by probability of sentence given x vector equal to this probability of positive over probability of negative, which is called as prior probability, these two, and then measure the conditional probability, just ratio of the conditional probability for both positive class and negative class. Probability of x1 for positive over probability of x1 for negative multiplied by probability of x2 for positive, probability of x2 for negative, up to number of words in the given sentence. When you simplify this equation, it would become like this: positive probability of positive divided by probability of negative. This can be written as I equal to 1 to n number of words in the sentence, and then p of xi given it is positive over probability of xi, it's a negative class. Now it looks simple. What this formula is? This is our mapping function f of x for our formula. So, in order to calculate this f of x, what do we need? We need to know this class probabilities. These are the probability scores that we need to know. One is probability of, this is a prior probability, and then we need to know probability for negative, and also for every word we need to know these probability scores. Probability of xi in given word for the positive class, probability of xi for the negative class. Now, next we will see how we calculate these probability score. Let's take an example, the same sentence. One is movie review 1, sentence 1, which is I liked the movie. I am just using the same sentence again and again, so it would be easy for us to follow. So, I am just giving you the same example. The movie was awesome. And then the second one is I did not like the movie. The movie was boring. Next, tell me what is the next step? You need to apply pre-processing. Whoever is new to this class, please look back and see my previous videos and learn about these pre-processing steps and the simple formula for the Bayesian classifier. In the first sentence, after applying this pre-processing step, we need to remove these words I, the, was. These words will get removed. Stop words, oh, not. This one is very important. The word not is very important for our classifier. It has the negative sentiment. And did will get removed, the will get removed, the will get removed, was will get removed. And then how would I sentence looks like? This would look like movie, movie, awesome. And my second sentence would look like not like movie, movie, bore. After applying stemming, boring will become bore, liked will become like. Then next, what is the next step in data pre-processing? We need to create the vocabulary. The vocabulary for these two sentences are like, movie, awesome, not, bore. Whenever this Bayesian classifier model, this each words represents our input vector or input feature x1, x2, x3, x4 and x5. This is our vocabulary. In our formula, do you remember what we need to calculate? The class prior probabilities, and then we need to calculate the conditional probabilities. So next we will do the frequency count. How many times this like appeared in the positive sentence and negative sentence? This is our positive sentence, this is our negative sentence. Like appeared only in positive, not in negative. And the movie appeared 2 times on both positive and negative. And when I look at awesome, it appeared only positive sentence, it is not appeared on negative sentence. Not appeared only in negative sentence, it is not appeared in positive. And bore, same thing. The next step is calculation of probability of each word xi for the positive class. Do you remember how do we calculate this probability score? Probability of xi, for this first one it is probability of this word like for the positive class, this class. How many, what is the frequency, total frequency for this positive class? It is 4. For negative class it is 5. This is total number of words in positive class and this is total number of words in negative class. How do we calculate this probability score? The probability score is just having the number of counts for this like, how many times it appeared, 1 time in positive class, and total number of words in this positive class is 4. This is how we calculate the probability. So this value would become 1 by 4, and next one is 2 by 4, 1 by 4, 0 by 4, 0 by 4. Similarly, we calculate P of xi for negative class. When I calculate this one, what do I get? Next one is for negative class, do the same calculation for the negative class. What is the frequency for like? It is 0. 0 divided by what is the total number? It's 5. So 0 divided by 5. Oh, do you remember that like appeared in negative sentence also? So that's how it appeared. I did not like the movie. So we need to have one for the negative class also. It becomes 1 by 4. For this one, 2 divided by 4. For this one, 0 divided by 4. This one, 1 divided by 4. I made a mistake. It is not 4. The total frequency for the negative class is 5. So what do? I remove this 4 and make it as 5. 5, 2 by 5, 0 by 5, 1 by 5, and finally here 1 by 5. So now we know these two probabilities and we know the class probability. Probability for the positive classes, first we need to look at the total number of words in the positive and negative. It is 4 and 5. Usually in machine learning model, it is very useful to have a balanced sample. That means have the same number of words in positive class and negative class equally, so that this probability for positive class will be zero point 0.5 and probability for negative class would be zero point 0.5. For just for simplifying the problem, we assume that this is 0.5, 0.5. And in order to calculate our mapping function, do you remember this formula? What is this formula? The formula is, for all the words, we need to calculate the ratio of these probabilities, positive, and we do not need to use this class probability since it is 0.5, 0.5, probability of positive, probability of negative. This term can be eliminated from our equation. So, after simplifying, we just use this simplified version of our equation. So, this looks, our model looks simple. Now, what we need to do is just calculate these probabilities. For the first word, what is the ratio? 1 by 4, and then for negative class it is 1 by 5, and for next one, second word, it is 2 divided by 4, and then which is divided by, and here it becomes 1 by 4. When I do this calculation, it becomes 5 divided by 0. So, there is a issue. How do we overcome this issue? We are getting into the trouble of dividing a number over 0. In order to avoid the situation, we apply Laplace smoothing. So, for this formula, in order to avoid this 0 division, we just slightly modify this formula. For this probability of xi for positive is rewritten as the frequency for the particular word, frequency for word I plus 1, just add 1 in the numerator, and in the denominator, what is the denominator? Here total number of words for the positive class, total number of words for positive class, plus then add the size of this class. What is the size of the class? Which is unique words in this entire vocabulary. There are 5 words. Now we need to add just 1 in the numerator and 5 in the denominator. So whatever calculation we do is exactly the same. Extra, we need to add 1 in the numerator and 5 in the numerator. What is this 5? 5 represents the number of unique words in this vocabulary. This 5, and just add this one. Similarly, for negative class, it is exactly the same. Size of the vocabulary is 5. So now we avoided the 0 division problem. Next, what is the next step? Yeah, so continue this formula. Instead of using this values, I just modified it, and the form that value becomes, let me erase this one, and use the modified values after applying Laplace smoothing. 2 by 9 for the positive class, and the negative class it should be reverse of 10 divided by 2, and then again calculate 3 by 9, and then this one is 10 by 3. Similarly, for the third one it is 2 by 9, 10 by 1, and then for next one is 1 by 9, 10 by 2, then finally 1 by 9, 10 by 2. Multiply all these numbers, then you will get the final answer. It is coming around something like 10 by 9, 10 by 9 to 20 by 9. So, when you calculate this number, it would be greater than 1. Whenever we already saw this, whenever the value is greater than 1, it represents the sentiment of the word is positive, otherwise negative. Here, do you see any issue in this calculation? It looks very simple. That means we do have a just a mapping function. For this mapping function, we need to calculate this simple uh, probabilities and then multiply all these probability and come up with this our final y prime. It looks very simple and elegant. Then what is the problem here in the computation? One is a division by 0 that we can overcome by applying Laplace smoothing. And I see another issue here. For just for 4 words in this vocabulary, we are multiplying so many decimals. If it is greater than 0, there won't be a problem. If for the negative class, if we multiply very small number so many times, if it is very low, then we end up in kind of that computation becomes cumbersome, and we need to overcome this. In order to avoid multiplying small numbers so many times, we can apply another method, which is taking the log ratio. We will see how to apply that log ratio method and come up with that final Bayesian classifier for sentiment analysis. Till then, thank you. Bye.